So we have problem. Let's solve this problem. Two cars, each having a speed of 50 km per hour, are headed to each other on the same straight track. Okay. We have two cars. This is one car. Okay, this is one car. And this is another car. This is another car. So this is two cars. And they're heading to each other. They're heading to each other. And we know the speed. This is V1, this is V2. And we know that speed of the first car equal to the speed of the second car. And it's a 50 kilometers per hour. Okay. And bird can fly 60 kilometers when the... So we have a bird which... Okay. Let's say we have here a bird. This is a bird. This is a bird. And this bird fly from this car to here, and then from this car back to this car, and so on. So it's a kind of little strange bird, but anyway. And we know the speed of this bird. The speed of this bird is 60 kilometers per hour. 60 kilometers per hour. So in fact, this bird a little faster than this car. Okay, the bird is faster. It flies to this car, then returns back, then returns. And what they ask us to find? What is the total distance the bird travels before the cars meet? So the cars goes to each other, and before they meet, what distance our bird make? Not our bird, just bird. Okay, let's write the distance made by the bird before the car meet. We need to find. Okay, it maybe looks like difficult problems because we should take into an account speed of this car and speed of this car, speed of the bird, and bird goes there and back and then back, and we don't know how many times our bird has time to go from one car to another. So maybe it looks like we need to make very complex equation and to have supercomputer to solve this equation, but actually everything I think much simpler. So we have speed of each of these cars, so we can find time when they meet, how much time our bird has to fly there and back. Yeah, this is the same time, yeah, because we need to find the distance made by the bird before the car meet. So let's find in what time our cars going to meet. Okay, the distance between the cars is speed with which the cars are approaching one another. So this speed, it's a sum of speed of each of the cars. It's like cumulative speed. So the distance equals speed multiply time. From here we can find time before our two cars meet each other. Actually, time before they collapse, if they go to each other. Time equals distance divided by speed. distance divided by speed. Distance 80 kilometers apart. So the distance between the cars is 80 kilometers. Okay, and we write here 80 kilometers divided by speed with which these cars are approaching each other, and the speed is the sum of speed of every one of the cars. So it's 50 plus 50. So it's 80 divided by 100. So it's 8 divided by 10. So it's simple ratio. Let's present it as it's presented as decimal. It's 0.8 hour. So this is the time our cars have before collision and our bird has for flying then back, then back, then back. To do this strange action of this bird. And they ask us what distance the bird going to make before the meeting of the cars. Again, we can use the same distance made by the bird equals speed of the bird, and we know the speed of the bird, multiplied by time, and the time our bird has for moving and the time before car meets at the same time, so we already know time. Okay, speed of the bird 60 kilometers per hour multiplied by 0.8. It's 48 kilometers. So before the cars meet, our bird going to make distance 48 kilometers. We don't know how many times the bird going to move there and back, but we just know the time the bird has and we know the speed, and of course we don't take into account some things like bird reduce speed before when approaching car. No, it doesn't. Or then have acceleration. No, we assume like the bird has the same speed all the time, and with this assumption we got such